So last time we used a couple of commands to find files in the Linux file system. One of them was locate. For example, locate bin zip, and it gives us a list of files that contain this word that we are using. Another command was find, which searches all the files and directories in a given path and tries to match some patterns. So it finds the ones that match some pattern. For example, it matches only the directories with type D, or it matches only the files if with type F, and we can use other filters as well according to the size of the file. We can filter for the permissions of the file, etc. Today we will continue with another example with this command file. First of all, let's make some test directories and test files, so that we can do the examples on these directories. So I will create some empty files in the directory. First, let me create some directories. Make dir p test dir -100. So this option -p of command make directory means that it is going to create any paths, even if they do not exist. For example, this test directory does not exist, but it is going to create it, and it is going to create subdirectories as well. And if you remember, this is a shell expansion, curly brace shell expansion, which is like a range, and it will be replaced by 001, 002, 003, and so on up to 100. And so let's see what we have created. There is this test directory here. And we have created also these subdirectories from dir 001, dir 002, and so on up to dir 100. There are 100 directories or subdirectories of this directory test. And we can also use the command tree test. Okay. Now we will create some empty files inside these subdirectories. And to create an empty file, we use the command touch, and then test, and then dir 001 up to 100. And then here I am going to create some files, file from A to Z. So this command touch is taking actually lots of arguments, because this is expanded by the shell. And this is expanded to 100 subdirectories, and this is expanded to 26 letters of the alphabet. And so it is going to get actually in total 2600, 2600 arguments, and it is going to create this many files, 2600 empty files. So let's check what we have created, what we have dir 001. So we have 26 files from file A to file Z in this directory, and the same in the second directory, and so on. These are empty files, but it doesn't matter. For testing that we are doing, they are fine. And now let's try to find all the files that have the name file A in the directory test. So the command is find, and then where it is going to search in the directory test, and then type file name file A. So we are applying two filters. First of all, we are checking for files, and then the name of the file should be file A. And it is finding all of these files in all the subdirectories. And if we count the number of the results, actually there are 100 of such files, because there are 100 such directories, subdirectories of directory test. Now let's create a timestamp file. Touch test. So there is this file that we just created under the directory test. And with the command stat, we can see some statistics about this file. For example, the size is 0 because it is an empty file. This is the file name. And then these are access rights, the username and the group to which it belongs. So it belongs to user 1, and the group is student. And also access time, last access time, last modification time, last change time, and when it was created, creation time. So these are date and time. And if I touch it again and look at the stats, and now let's compare the times. So the birth time is the same because this is the creation time of the file. Access time and modification time and change time are different. They are modified. So this command touch actually changes the access time of a file. If it is an existing time, if it is an existing file, a file that already exists, it is going to change the access time of this file. Otherwise, if the file does not exist, it is going to create a new file. So we can use the command touch both to create an empty file or to change the access time of an existing file. Now, using the command find, we can update the access time. We can update the access time of all the files with name file B, for example. So find on the directory test, type file name file B. So it is going to find all the files with this name. And then we are going to execute the command touch to each of these files. And this is representing the file name that is being passed to this command. And it needs a semicolon at the end of the command, but we are escaping it, otherwise the shell is going to interpret this semicolon. And also we are enclosing these two curly braces in single quotes in order to prevent shell from escaping it. And we can also do this with single quotes as well. So what we just did is that we modified the time of all the file B, all the files with name file B in this directory. Now let's see how we can compare times of files, or how we can find time files based on their modification time or access time. So we are going to find on the directory test, type file, and then we can use this this condition or this filter, newer than test timestamp. So we are going to find all the files that are newer than test timestamp. And actually, we modified this file B after we modified timestamp. So we should be able to find all these file B files, all the files with name file B. So we are looking for all the files that are newer than timestamp. All the other files are were created before we created this file, but we modified these file B files after we created this this file, and so this test is comparing the modification time of each file with the modification time or the creation time, the modification time of this one, and it is finding all the files that are newer than this file. And if we count them, there are 100 of them because we modified all file B, all the files with name file B. We have seen an example last time about finding all the files and directories with bad permissions. So let's do it again in this test directory. Find test, and now we are going to use two conditions combined with the logical operator OR. So we are including these conditions in parentheses, and also we make sure that there are empty spaces around the parentheses. Otherwise, the shell will not interpret it correctly. So it is the test is that it should be a file, and it should not have permission 0, 0. So with this test, we are finding all the files with bad permissions. So all the files that do not have permission 0600. And now we are going to look for the directories which do not have good permission. No. This is type here. So we are finding all the files and directories that do not have good permissions, and almost all of them do not have good permissions. And now we can add an action to the command above. In order to, we can add some actions to the command above in order to fix these permissions. For example, here, after we find such files, then we say execute the command. Which command? Change mode 600, and then to the file that is found, and then we end the command here. And then we can add an action to the other condition. Exec change mode again, but this time we set the mode 0700 or 700. It is okay. This is okay too. And then or this one. Okay, we did not have to include this this counting command, but now let's try to find again the files and permissions, the files and the directories with bad permissions. None of them. We cannot find anyone because we just fixed them. And actually, the command that we used above is a little bit complex, and it is not necessarily complex. It doesn't have to be so complex because in this case we can use two simple commands. For example, we can use this command, find test type file not permission 0600 exec change mode 0600, and then so we can use this command, and we can use a second one for the directories. Type directory not permission 0700 exec change mode. So these two commands are actually equivalent to this to this complex command because these expressions are combined with OR, and this is actually simpler. But we use this complex command just as an illustration to show that it is possible. It is possible to build complex logical expressions with command find. So just to show what is possible, and in this case we can, in case that the expression is complex, we can also use this parenthesis to enclose the expression to make it its meaning clear. And let's see some other test commands that we can use with find, or some filters that we can use with the command find. For example, we can find all the files that were modified more than 1 minute ago. Find in the directory test all the files or files or directories. So These are all the files and directories that were modified more than 1 minute ago. And actually, all of them were modified more than 1 minute ago. Or we can find the files and directories that were modified less than 10 minutes ago. And actually, all of them were modified less than 10 minutes ago. And when I say modified, it is about the content or the attributes. So the modification includes the modification of the content of the files and modification of the attributes. Attributes are permissions. For example, read, write, execute for the owner, for the group, and for the other users. So with this filter, cmin, we are checking for the modification time of the and the modification means both for the content and the attributes. And if we want to check only for the modification of the content, then we use this filter -m min. And in this case, we are checking for the files that are whose content is modified more than 1 minute ago. Or let's find the files that whose content is modified less than 10 minutes ago. And we see that no files were modified, the content of the file were modified less than 10 minutes ago. And there is another filter, which is ctime. And this is also this is similar to cmin, but this is not for minutes. This is for in days. So if I say +7, it is going to search for files whose content or attributes were modified more than seven days ago. And if I say -7, it means modified less than 7 days ago. And now we see that we get results because all the files and directories in the directory test were created and modified less than 7 days ago. And there is also another filter, empty, which is searching for files and directories which are empty. And empty. And if we count them, then we see that there are 2,601 files which are empty. And this is correct because each directory contains 26 files. There are 100 directories. And besides, we have also this file. And this file is empty as well. And let's try, for example, to write something to save something into this file so that it is not empty anymore. So now it is not empty. And let's run the previous test again. And now we see that there are 2,600 files that are empty, because this one is not empty now. Now I'm going to start with another topic, which is also important both on Linux commands and also in programming sometimes. And these are regular expressions. And to test regular expressions, we will use the command grep, which means global regular expression print. So it is looking for files that match a certain word or expression, and it is looking for lines in a file which match a certain word or expression, and it is printing these lines that are matching. Regular expressions are used on many other Linux commands as well, but for testing, we are going to use only this command for the time being, grep. For example, let's say that we have this command, and we can pipe the output of this command to the command grep. And we are filtering only the lines that contain the word zip. In order to explore grep, let's create some text files that we can use for searching. So I'm redirecting the output of command ls and saving it to this file. The same for the output of this command, and let's check actually. So this is the output of the command ls here. And so we have these 5 files which have output from this command ls, and let us try to use the command grep to search on these files. So I'm typing. Here is this is the expression that is going to be searched, and here are the files where it is going to search. And we have talked that this star is going to be expanded by the shell, and actually in place of this, the shell is going to substitute all of these files. And we see the result of the command grep. It is showing the file and the line that is matching. So this line in this file has a match, and also the match is shown in red color, the part that matches the expression. And if we are interested only on the files that that have a match, but not the lines that match, then we can use this option -L. So with this option -L, it is going to show only the files that contain some lines that match, but not actually the lines that that match this expression or this word. For the time being, this is just a simple word, but it can be a regular expression, and we will see it soon. And with capital L, actually, it is showing the files that do not match, that do not contain any match of this. So it is the opposite of L. It is opposite of lowercase l. Now let's try something, or if we use the option H, for example, then it is going to show the lines that match, but not the file. We don't care in which file it is the line that matches. We just want to see the lines that match. Now let's replace this bzip with something like this. Instead of b, I'm going to place this dot. This dot is a meta character in regular expression. So it is a regular expression meta character. And it actually means if we use a dot, it is going to match any character. So we see that it is matching nzip, for example. It is matching gzip. It is matching ezip, basically nzip. So it matches actually any character. So it is a meta character that is used to match anything, any letter, any character. And another meta character is this caret. And this is used as an anchor. So it is going to match this zip, but only if it is at the beginning of the line. So we see the results. All the results are matching at the beginning of the line. So it is because of this meta character. Another meta character is this $sign at the end of the expression. And this $sign is also an anchor, and in this case, this word zip is going to match only at the end of the line. So it is showing us all the lines that have a zip at the end of the line. And of course, we can use both of them, match at the beginning and match the beginning of the line and the end of the line. And so it is going to display all the lines that contain only zip, because only this contains zip that matches the beginning and the end of the line. And we can use this this bracket expression. And what this means is that all this expression can match only B or G. So any of the characters in the bracket expression. So either bzip or gzip will be matched. So we have bzip here and we have gzip here, and no other combinations or no other characters. And if we put a caret just at the beginning, just after the opening bracket, This means all the characters that are not B or G. So this has a negative effect. So it will match any character that is not B or G. And we see that we have nzip, we have ezip, etc. We have mzip here, but not bzip or gzip. So this as a meta character after this bracket means anything but the following characters. Any character except the ones that are inside the bracket. And this special meaning of the character is only if it is at the starting of the list. So only if it is immediately after the opening bracket. If it is somewhere in the list, then it is not a special character. It just represents itself. So in this case, it is this regular expression is going to match all the lines that contain bzip or gzip or contain this. Because in this case, this is just a normal character. It is not a meta character. It just represents itself. And if we want to find all the lines that start with an uppercase letter, we can do something like this. So this is to match the start of the line, and then we can list all the uppercase letters of the alphabet. So this is matching the beginning of line, and this is matching any uppercase letter. And so the result are all the lines that start with an uppercase. But there is an easier way to write this range of characters. We can just type A and then minus and then Z. And this will be interpreted as a range of characters from A to Z, from capital A to capital Z. And the result will be the same. It has the same result. If we want to find all the lines that start either with an uppercase or with a lowercase or with a digit, then we can type this expression. So this is a range from A to Z. This is another range from lowercase a to lowercase z. This is another range from 0 to 9. So here it is going to list all the lines that start either with a number or with an uppercase letter or with a lowercase letter. And again, this minus is a meta character, which means a range from this character to this character. And it makes sense if it is in between two characters. So it is interpreted as a meta character if it is in between two characters. If we have something like this, for example, or something like this, in this case, it is not interpreted as a meta character, but as a minus itself, as a simple character. It represents itself. again, we will get some results, but we see that here we have all the lines that start with either A or Z, or lowercase characters, or a digit, or start with a minus. But we don't have a character lines that start with B, for example, because this is not a range. And this list of characters, uppercase letters, lowercase letters, and digits, are called alphanumeric characters. So they include all alphabetic characters, lowercase and uppercase, and all the numbers or the digits. And we can represent this class of letters with this character class, alnum. So the character class is this one. The character class is this one, alnum. But we are including it inside square brackets, so that we tell the grep command that any alphanumeric character can be matched. So starting with any alphanumeric character. And some other character classes are, for example, alpha, which includes all alphabetic characters, lowercase and uppercase letters, or digit, for example. Digit. It includes all the numbers from 0 to 9. So all the digits from 0 to 9. Or another character class can be lower, which includes all the lowercase letters from lowercase a to lowercase z. Or upper, for example, which includes all the uppercase letters or capital letters. Or we can have space. This includes the space itself and a tab and a new line, maybe. And we can have, for example, punct character class, which includes all the punctuations. For example, exclamation point, dot, question mark, etc. And we have seen these character classes on shell expression as well. So they are used on regular expressions, can be used on a regular expression to define a regular expression. But we have seen them also on shell expansion. For example, if we say user bin and then upper and then star, then this is going to list all the files in the directory user bin that start with an uppercase letter. And then this star means after it, any other letters can be, it doesn't matter. So there's something wrong here. Okay, this doesn't work as expected. Anyway, so let's continue with something else. We can use a vertical bar to define alternative matching patterns. For example, if I say echo so we have a match here. This command is matching the input. And if I say, for example, echo again, we have a match. But if I say this again matches, so this regular expression is matching this line because we have this kind of or meta character or alternative matching. So it can, if the expression on the left matches or the expression on the right matches, then the whole expression is matching. And we are escaping this with a slash in order to make it a meta character. Otherwise, it will be treated as a simple character. And the command grep also has an option minus capital E, which means extended regular expression, which modifies the syntax of regular expression a bit. And in extended regular expressions, this vertical bar is a meta character, is an or meta character itself. So we don't need to escape it with a slash. And if we want to use it as a simple character to represent itself, then we can escape it in case that we are using this option minus capital E. But by default, with the option minus capital E, this is considered a meta character. And this expression can match either this one or, for example, so this line can be matched as well by this expression. And if we try, for example, with C, this does not match. So this expression does not match this line. But we can extend this expression like this. If we extend it like this, in this case, it is going to match this line. Because this part of the expression does not match it. This part does not match it. But this part of the expression does match the line. So we have a match. So other meta characters that are other characters that are considered as meta characters with the option minus E, similar to this vertical bar, are parentheses or curly braces or this question mark or plus, etc. So if we are using this option minus capital E, then we can use this as meta characters, and we will see some examples later. Otherwise, if we don't use this option minus E, then we have to escape them in order to be considered as meta characters. We have to use them like this. So let's see some other examples with regular expressions. We need a dictionary of British words, which is in a package. Let's check whether it is installed. So we have this package installed. It is installed, and because this package is installed, then we should be able to find the dictionary in a certain directory. So in this directory, user share dic, we have these words. Which is actually a link to this file. But if we check the content of this, for example, with less, we see that it is a list of British words. So it is like a dictionary that contains a number of British words. And if we want to know how many numbers of how many words are there, we can count the number of lines, and there are 234,937 British words in this dictionary. And now suppose that we are solving a crossword puzzle. So we are trying to find a word which has 5 letters, and the third letter is J, and the last letter is R. We can use the command grep and a regular expression and the British dictionary that we just saw to solve this problem. And we can do it like this: grep minus I. This option minus I means case insensitive, so it will match both lowercase and uppercase letters. And we need a word of that has 5 letters. So this regular expression is matching a word of 5 letters. So this is the beginning of line, this is the end of line, this will match the end of line, and each of these letters, each of these dots is a meta character that can match any letter. So this regular expression will match any letters of 5 characters, and we are going to match it. We are going to search on this file, user share dict words. And so it is giving as a result all the words that have 5 characters. But actually, our puzzle is that, our puzzle says that the third character is a J. So the third character is a J, and the last character is an R. And so let's see what we get. And so we get only these 3 words that that match this description. So a 5-letter word where the third letter is a J and the last letter is an R. And so we can use this British dictionary and the command grep to, they can help us to solve word puzzles and crosswords. Now let's see another example. let's say that we want to check a phone number for validity, and we consider a phone number to be valid if it is in the form 3 digits enclosed in parentheses, and then 3 other digits, and then minus, and then 4 other digits. So this is a valid phone number format. Or it can also be considered valid if it is in the form 3 digits, a space, 3 other digits, a minus, and then 4 digits. So these two formats are considered valid phone number formats. For example, this is a valid phone number, and also and this is also a valid phone number. Now we want to check whether this line is a valid phone number using grep and regular expression. And so we can send the command of, we can send the output of echo, we can pipe it to the command grep. And then here we are going to write the regular expression. But first, let's use this option minus capital E, which is going to make it writing the expression easier. And now we want to match. First of all, let's match the beginning and the end of line. And here we want to match 3 digits. So this 0 minus 9 matches 1 digit. This is going to match another digit. And this is going to match another digit. And then a space. And then let's match 3 other digits. And then a minus, and then 4 more digits. A digit. The second one. The third one. And the fourth one. But we have forgotten something here. We also need to match a parenthesis, if there is a parenthesis, and a closing parenthesis here, if there is a closing parenthesis. And because we are using this minus E option, these parentheses are treated as meta characters. If we want it to match to be a simple character, to match just the parentheses, then we have to escape these two. And besides this, we also have to add this question mark after parentheses and a question mark after this one. This question mark means that the character before can be in the line or cannot be. It will match in both cases, both if the character is and if the character is not there. So let's check. So this is a correct regular expression. It is matching this phone number. Now let's try with missing parentheses, the other correct format of phone numbers. And again, it is matching this one, and it is because of these question marks here, which tell that this parenthesis either can be there in the line or it cannot be. In both cases, it is going to match. And now let's try something that does not match. For example, this is not a valid phone number. In this case, it is not going to match. it is matching this one. And if we want to remove, remove this option -e, now this parenthesis is a simple character. It is not a meta character. It represents itself. So we can remove the slash or the escaping before it. Also, we can remove the escaping before this one. However, now we have to escape. We have to escape these question marks, because question marks are simple characters by themselves, and if we want to use them as a meta characters, in this case, we have to escape them. And let's try it. Okay, it matches. So we can use either this one or this one, and accordingly escape characters or meta characters as needed. And now we can make this expression a little bit simpler, because it is difficult to write so many 0, -9, 0, -9, 0, -9, and we can simplify it like this. This number 3 inside curly braces, and because we are using this option -e, these curly braces are meta characters. So this number 3 shows the number of repetitions. So it is going to repeat the character in front of it, or the expression in front of it, this many times, 3 times. So we will have a match if the expression, if the character in front of it is repeated 3 times. So if we have 3 digits, and we can do the same for the others as well. So 3 digits and 4 digits. And we see that again, it is matching. So as I said, this x, where x is a number, this shows how many times the character in front of this is repeated. So if it is 5, for example, and here we have an a, for example, then this is going to match this one with 5 a's. If it is, for example, it can actually be a range. For example, it can be 5, 8, for example. Then it is going to match if the character in front of it is repeated from 5 to 8 times. So this one will match because there are 5 A's, but this one will match as well because there are 6 A's. And this one is going to match as well because there are 7 A's. This one is going to match as well because there are 8 A's. But now it is not going to match because there are 9 A's. So now it does not match anymore because there are 9 A's. There are not 5 to 8 A's. And also, if there are less, it is not going to match again. So the general format of this curly braces is x from x to y, or from n to m. And n and m can also be 0. For example, if we say 0, 1, then the character in front of the curly brace expression is going to match will be matched either if it is 0 times or 1 time. And actually, this is equivalent. This is equivalent to this question mark. So in place of this question mark, we can also use curly brace expression like this. So we can say 0, 1. So it is going to match either if it is only once or if it is 0 times. Again, 0, 1. And without commas, it is going to match again. And we will continue next time again with regular expressions. So, but let's stop today and continue on Friday.